My name is Vladimir Korikov, and this is the Domain-Driven Design in Practice course. In this module, we will discuss DDD concepts that we didn't cover in our sample project, and some further possible ways in which our application can evolve in the future. We will also look at some common anti-patterns programmers employ when they start applying DDD principles in practice. One of debatable topics in DDD is whether to always keep entities and value objects in a valid state or allow them to reside in an invalid state and check that state later on, for example before saving them to the database. This topic is best expressed with an example. Let's say we have a domain entity cargo with a max weight property. Let's also say it contains several items, each of which has its own weight, and there is an invariant saying that a cargo cannot contain a number of items, the total weight of which exceeds the maximum weight the cargo can handle. This is how we could express the domain adhering to the always valid approach. You can see we first create a cargo with some max weight value, and then check that this maximum weight would not be exceeded in the addItem method call. If it is, we throw an exception signalizing that the invariant of the entity is violated. That way, we don't allow the class to enter an invalid state. This is, on the other hand, how we could solve the problem adhering to the not always valid approach. You can see we allow any number of products to be added to the cargo. To validate whether or not the invariants are broken, we introduce a separate isValid method. Both techniques has their own pros and cons. The main benefit of the always valid approach is that we as programmers can be sure the objects we are working with always reside in a valid state whenever we accept them as input parameters or get them as a result of some operation. On the other hand, the not always valid approach allows us to gather most of the validations for an entity in a single place and thus simplify the validation logic. So what approach to choose and why? Despite the benefits that the not always valid approach provides, I strongly recommend you adhere to the always valid approach. There are two reasons for that. First of all, it removes temporal coupling. With the opposite technique, you must always remember to call the isValid method before persisting an entity to the database or before executing some business-critical operation. This often ends up to be an error-prone way to build a domain model. Secondly, the always valid approach helps with the don't repeat yourself principle. In other words, it helps eliminate duplications which inevitably take place with the not always valid approach because of the necessity to validate domain entities multiple times during a single business operation. Overall, it is better to adhere to the guideline stating that all domain entities and value objects should always reside in a valid state and maintain their invariants during the full length of their lifetime. A violation of any invariant in the domain model should signalize a bug and lead to a failure in order to protect the persistent state. This principle is often referred to as fail fast and is one of the most important principles of software development. You can read more about it here. So, if all domain classes reside in a valid state, where exactly should one perform validations? In the example above, where should we check that an item can be added to a cargo? The best place to perform such validations is the boundary of the domain layer in the application services. You saw this technique in our project. Whenever we needed to validate whether a snack could be bought from a snack machine or a sum of money could be taken from an ATM, we performed validations in the viewModels first, and only after that performed the corresponding operation upon the domain entities. This way, we ensured all classes in our domain model always reside in a valid state. Otherwise, our domain classes throw exceptions which lead to application crash. One of the DDD concepts we didn't use in our sample application is factory. Factory is not a DDD notion per se, it was first described by the gang of 4 in the Design Patterns book, but it's still worth discussing. A factory is a class which is responsible for creation of domain entities. Sometimes creating an entity requires a lot of work in the sense that you need to retrieve some information from different places and combine different pieces of it together in a certain way. In this case, it would be unwise to commission this responsibility to the entity itself, because construction of an entity has nothing to do with exploiting it after that. Think about it this way. A car engine is a complex device, but it's not responsible for self-construction. That is what engine factories are for. Designing an engine which can build itself is in theory a feasible task, but such device would most likely be too expensive and unstable compared to a classic car engine. The same reasoning is applicable to domain entities. If the logic for creating them is complex, it is better to extract this responsibility to a separate factory class. That would help keep the entity simple and thus more maintainable. Just as repositories, factories create whole aggregates, not just separate entities in it. At the same time, don't add a separate factory in case the initialization logic is simple enough. Class constructors would be a better option in such situation. You saw that in our domain model we didn't introduce any factories. That's because there wasn't any complex business logic associated to the creation of our entities. Another important DDD concept we didn't discuss yet is domain services. A domain service is a class which doesn't have any state associated with it and which contains some domain logic. The best way to think about domain services is to view them as containers for the knowledge which doesn't belong to any entity or value object but is still essential for your domain. It might happen that an operation is related to some entity, but representing it as a method in that entity wouldn't make much sense. In this case, it is probably a good idea to delegate this operation to a domain service. An example here would be a car service. We don't entrust a responsibility to maintain a vehicle to the vehicle itself, it's just not the way it works in the real world. A better decision would be to introduce a separate domain service responsible for that operation. A question which often arises when people start thinking of domain services is how they differ from application services. The difference here is that an application service resides outside of the domain layer, whereas a domain service is inside of it. It means that application services are in charge of communicating with the outside world and shouldn't contain any domain logic. What they should do instead is delegate the execution to the domain classes, such as entities, repositories, and domain services. Domain services, on the other hand, do contain domain knowledge and shouldn't communicate with the classes outside of the domain layer, the two innermost layers in the Onion architecture. We didn't have any domain services in our project, but at some point we could. For example, if we had a requirement to distribute a given amount of products evenly among several snack machines, that would be a task for a domain service, because it is a domain-related operation and it doesn't fit the responsibilities of any existing entity in our domain. There are several pitfalls programmers starting with DDD may run into, and it's important to know about them. One of such pitfalls is Anemic domain model. If you try to follow DDD principles, then you are probably not subjected to this anti-pattern, but it's still worthwhile to know about it. Anemic domain model stands for separating data and methods working on that data to separate classes. It usually means that entities in such model contain only data and all domain logic is extracted to domain services. In our application, for example, Anemic domain model would look like this. You can see the snack machine entity contains only data, money inside, money in transaction, and the collection of slots. All operations upon the snack machine are delegated to the snack machine domain service. In object-oriented programming languages, introducing an Anemic domain model is generally a bad idea because it hinders application of many OOP design patterns and best practices. The most important drawback here is that it often leads to poor encapsulation. Note that the properties in the snack machine entities are all public. That's no coincidence. The only way to enable separation of data and logic into different classes is to expose the internal structure of domain entities and thus break their encapsulation. Such code is much harder to maintain because its invariance can be easily broken. You can read more about Anemic domain model in this article written by Martin Fowler. Another anti-pattern I'd like to mention is fat entities. This anti-pattern resides on the other part of the spectrum of bad design decisions comparing to Anemic domain model and basically stands for putting too much logic to entities. There is a fine balance between Anemic domain model and fat entities, and it's sometimes hard to find it. So how do you know that you put too much logic to your entities? One of the clues is that your entities start having responsibilities that seem unnatural to them. For example, in our sample application, we could commission the duty to update the balance of the head office to the ATM entity. Such responsibility doesn't make a lot of sense in our domain because ATMs don't actually update the balance of our office. Nevertheless, we could do that, and that would be a sign of the ATM entity getting too fat. Another symptom of this anti-pattern is when domain entities start looking up data in the database or communicating with outer layers of the Onion architecture. In other words, when we break isolation and allow the innermost layer depend on the classes from outer layers. To avoid falling into the trap of fat entities, you need to make sure your domain model is properly isolated, and all entities' responsibilities make sense from the domain point of view. There also is a quite common anti-pattern involving repositories. It regards to the way a repository initializes domain entities that are returned in different methods. Let's elaborate on that. Let's say, for example, that we have three scenarios, each of which requires a different set of data from snack machines. The first one needs all data associated with snack machines in the database, so we create a method in our repository like this. Another scenario doesn't need slots from the database, so we decide to create a separate method which also returns all snack machines from the database, but doesn't fetch slots attached to them. This would allow us to improve the performance of fetch operation, because we reduce the amount of data we retrieve from the database. And finally, the third scenario requires only the machine's identifiers, so we add a third method which also returns a list of snack machines, but fills only the ID property of them. All other fields remain empty. This allows us to improve the database select query even further. This technique leaves us with three methods. Each of them is perfectly justified from the performance point of view, because each of them returns only the data that is required in one particular case. The problem with this approach, however, is that these two methods return partially initialized entities. And with partially initialized properties, we cannot ensure validity of the entities and thus cannot adhere to the always valid approach we discussed previously. In our case, snack machines should always contain exactly 3 slots, and by not returning them along with the machines, we violate this business rule. Partial initialization leads to inability to maintain invariance of the entities and thus should be avoided. If your repository returns a domain entity, make sure it is fully initialized, meaning that all its properties are filled out. But what should we do in case we really need the performance benefits partial initialization provides? The solution here is not to use domain entities as returning objects in such situations. So in this case, we can keep the 3 methods but use other data structures instead of snack machine entities. For the method that returns all machine properties except slots, we can use data transfer objects and put this data there. For the third method, we can employ the long type and return IDs as is without wrapping them into a separate class. Not only does this approach solve the problem with the validity of snack machines, but it also makes explicit what data the repository methods return. This DTO class doesn't contain a slot collection, so we won't be able to accidentally access it when we'll be processing the DTO on the client side. The compiler would notify us about that. The last anti-pattern I'd like to talk about is mechanical approach to domain-driven design. I've seen several times how programmers start treating their domain mechanically. Whenever they defined a new concept in the domain model, they automatically created several classes for it: a class for the concept itself, a repository, a factory, and a domain service. They did that even if there was no need for those classes. Don't do that. Not only does such approach violate the Yagni principle, it also greatly diminishes the benefits of domain-driven design. Domain modeling is not something we can automate or commission to external tools. The act of modeling is closely related to learning. When we build our domain model, we first and foremost learn the domain we are working in. The code is an artifact of that learning process. Mechanical approach to building the model, as well as mechanical approach to learning, doesn't do any good. The only way to perform that is to do it thoughtfully. It also means that such tools as code generation and scaffolding don't help with this process either. If you find yourself relying on a code generation tool for building your domain model, you are most likely falling into the trap of mechanical approach to domain-driven design. Let's overview our application and see what further enhancements it can potentially take in the future. This is the map of the bounded contexts we ended up with in the previous module. Note that they are rather small in a sense that they contain few entities each. In a real-world application, they would probably be bigger because a typical application usually has much more requirements than we covered during this course. One of such requirements could be constructing a snack machine with different parameters, such as various number of slots, product specialization, and so on. And that can potentially be the direction in which the development will move further on. This additional functionality would belong to the snack machine bounded context. Also, we would probably need some kind of product supply for the snack machines our company owns in order to be able to refill them in a timely manner. This would belong to another bounded context, product supply, and it would contain its own version of the product entity, because the perspective from which the two bounded contexts view this entity differs, despite the fact these classes will represent the same physical product. For the ATM bounded context, we would probably need a collection service, which would refill cache in them. That would also be an additional bounded context with its own representation of ATMs. Note that as the application evolves, we can change the boundaries of the bounded contexts. That's perfectly fine as long as we state those changes explicitly in the context map. We can also change the type of physical isolation we employ for them. As the bounded contexts we work on grow, we can extract them into separate microservices and run them as independent applications. In this module, we discussed several DDD concepts we didn't touch upon in the previous modules. We talked about factories, classes that should be used to remove responsibility to properly initialize domain entities from the entities themselves. It's a good practice to employ that pattern in case the initialization logic gets too complex. We looked at the notion of domain services and how it differs from application services. The main difference here is that domain services reside inside the domain layer and thus contain domain knowledge, whereas application services coordinate the work between the domain layer and the outer world. We discussed the dichotomy of always valid versus not always valid approaches to entities and value objects. It's a good practice to adhere to the always valid way of working with domain objects and don't allow them to break their invariance. That would help eliminate duplications in code and adhere to the fail-fast principle. We talked about two anti-patterns that reside on the opposite side of the spectrum, anemic domain model and fat entities. Don't run to extremes and always keep balance between the two. We also talked about a common anti-pattern which sometimes arises when it comes to working with repositories. Make sure that every repository method returning a domain entity fully initializes that entity. If you need some partial data from your database, use data transfer objects instead. We discussed mechanical approach to domain-driven design. Domain modeling is one of the most important parts of software development. Make sure you treat it accordingly and pay close attention to that process. Finally, we talked about further enhancements our sample application can potentially take in the future. I'd like to provide a full list of resources I referenced during this course. If you have a full Pluralsight subscription, then you have an access to the source code of the project we were working on. If not, here is a link to it on GitHub. The other references regard to the topics we discussed in this course. This is my blog post on integration testing where I give an example of how to employ it in a typical DDD project. A question on Stack Overflow with a good explanation why you should always override the getHashCode method when you are overriding the equals method in your class. Here I write about different approaches to unit testing, namely test-first and code-first approaches. This is a nice explanation of what high-low algorithm is. In this video, Eric Evans gives a talk about bounded contexts with regards to microservices and also provides a good example of what context mapping is. Martin Fowler and James Lewis have written a great article on the topic of microservices, so if you want to learn more about it, it's a go-to resource. Here I write about cohesion and coupling and how these notions relate to each other. In this post, I describe different types of CQRS. The use of DTOs you saw in the previous modules essentially goes under the first type of it. This article depicts the fail-fast principle, and here you can read more about anemic domain model. We've made a great progress in this course. We've built a small but fairly complex application from the very beginning using domain-driven design principles. You saw how DDD helps us focus on the essential parts of the software, its domain model, and how it allows us to simplify this model and thus keep it maintainable in the long run. You learned the differences between entities and value objects, how to keep the model isolated in the face of working with a relational database and an ORM, how to work with aggregates, repositories, bounded contexts, and domain events. You also saw how DDD plays with unit testing and MVVM design pattern. Feel free to contact me. Here is my email, Twitter handle, and blog. This is Vladimir Horikov. Thank you for listening.